So z-scores are generally used to navigate your way around something called a standard normal distribution. And a standard normal distribution is a normal distribution where all your raw scores, so all the different values you have been converted to z-scores. Once this happens, you always get exactly the same distribution. So when everything's converted to a z-score, your units are z-scores. You always have a mean of 0, and you always have a standard deviation of 1. And this is called standardizing your normal distribution. So you take every score you have, turn it into a z-score, and then you have a standard normal distribution. And it should make some sense that the mean is equal to 0. If your z-score tells you how far away you are from the mean, a z-score of 0 means that you are exactly on top of the mean. It should also make sense that the standard deviation for this standard normal distribution is equal to 1, because you're counting in standard deviation. So 1 standard deviation is 1. And the important thing about standard normal distributions is that they are exactly the same in every way to the normal distribution that you converted them from. The only difference is the units. So it's like converting from feet to inches. Whatever units you had before, whether it's thefts or test scores, whatever the case might be, whatever your unit was before, once you convert to a standard normal distribution, you have z-scores as a unit, but everything else is exactly the same. And this is a really useful property because between z-scores and the standard normal distribution, you can find the probability of getting an outcome in between any two values that you can think of. So for example, if we were looking at our thefts example, you might want to know the probability that between 65 and 100 items will be stolen. And z-scores and the standard normal distribution will allow you to do this. And the reason for this is that the proportion of area under the curve between two values equals the probability of getting an observation between those values. And this is an idea that we already talked about and that we demonstrated using the 68-95-99-7 rule. But when we use the standard normal distribution, we're able to find an exact probability that falls between two values on the standard normal distribution. And we can do this because the standard normal distribution is exactly the same each time. It always has a mean of 0, it always has a standard deviation of 1, and it always has z-score units. So once you've converted your values into z-scores and you have a standard normal distribution, you can find the probability between any set of values. How do you find that? Well, statisticians before all of us have come up with a list of all the different values that fall between different z-scores on the standard normal distribution. And all you have to do is look at their list and find the right probability. No calculation involved once you have your z-scores. So I'm going to talk through an example now of exactly how that works, and really we're going to be following two steps. So if you want to find probabilities of getting an outcome between two values using z-scores, you're going to do two things. The first thing is going to be to convert your values of interest to z-scores. The second thing is going to be to find the area under the curve between those z-scores. And then you'll use something called a z-table, which is going to tell you the proportion of area that always falls between those z-scores on the standard normal distribution. So this probably sounds pretty vague as I'm talking about it, so I'm now going to hop back over to that document camera and go through an example.